Here's a genuinely surprising result from 2024. A team at Together AI showed that several ordinary open models, working together in layers, can beat a single top-tier proprietary model. They stacked whole language models the way you'd stack layers in a neural network and let each layer improve on the answers from the one below it. It's called Mixture of Agents, or MOA. Today we're breaking down how it's built, what makes it click, and why it works as well as it does. So let's trace the architecture, because the layered structure is the whole idea. It starts with a layer of proposer agents. Several different models each read the same prompt and answer it independently. Because they're distinct models with different training, you get a genuinely diverse set of candidate responses rather than one narrow take on the question, and that diversity is exactly what the later layers feed on. Then comes an aggregator layer. These agents take all of the previous layers' answers as reference material and synthesize an improved response out of them. They're not starting from a blank page. They're building on everything the proposers already produced, weighing the different attempts and pulling the best parts together. And you can repeat that. Each additional layer reads the answers from the layer below and refines them further. The output keeps getting sharpened as it flows upward, layer after layer, much like signals passing through a network, with every pass folding in more of what the earlier models got right. Finally, a single aggregator at the top produces the one answer that ships. All that layered collaboration gets distilled down into a single, polished response for the user. That's the shape of the whole system. Now, to appreciate what this buys you, compare it against the usual approach. Normally, you lean on one big model, and you get exactly one perspective. Whatever blind spots or quirks that model happens to have, they shape the entire answer because there's simply no second viewpoint anywhere in the loop to catch a weakness or balance it out. This approach brings many models into layers of proposers and aggregators. Different strengths get combined, and each layer refines the last. The finding they highlight is collaborativeness. Models write better answers when they can see other models' outputs, even weaker ones. So diversity becomes a strength rather than noise. Okay, 3 ideas capture what makes this approach tick. Layers of proposers, then aggregators. The proposers generate diverse first drafts, and the aggregators combine and refine them across successive layers. That stacked structure, whole models acting as units, is what turns a loose group of models into a single stronger system. Collaborativeness is the key insight. Models produce better answers when they're shown other models' outputs, even outputs from weaker ones. Seeing someone else's attempt seems to help a model raise its own game, and that effect is what the whole layer design is designed to exploit. Open models rivaling the best. Using only freely available models across a few layers, this method reached quality competitive with, and on some benchmarks beating, the strongest single proprietary systems. You pay for it in extra inference cost, since you're running many models instead of one. All right, let's lock in the 4 essentials. This method, from Together AI in 2024, layers whole models together to beat a single top-tier one. Proposer agents each answer. Aggregator agents synthesize their responses, and layers refine the results step by step. The insight is collaborativeness. Models write better answers when they can see the outputs of other models, even weaker ones. Using only open models, it rivaled the strongest single proprietary systems, trading extra compute for that gain. If you enjoy having AI ideas unpacked this way, you'll find a whole library of them over at Standarity.com. See you there.